I think we can start, and I'm sure I speak on behalf of everybody here, on behalf of Texas A&M, on behalf of the Texas A&M Energy Institute, the community here, that it's a great honor and pleasure to welcome our the Professor Dame Julia King, who is also the Baroness Brown of Cambridge. I don't know if you ever met a real Baroness, there she is. And it's she's also a member of the Lords. I don't know if, and it's a cross-bench appointment, so this is also quite rare, because often, I don't know how many of you follow the British politics at the moment, I'm sure you do, but the Lords is, so essentially you get from the political parties, and in very few cases of exceptional service and impact to society, education, and policy, you get these cross-bench appointments at the House of Lords. So it's a great pleasure. I had also, I have to tell you a personal also point about Julia. She was the Dean of Engineering at the period between 2004 and 2006, while I was there, of course, and I was the director of this interdisciplinary Center for Process Engineering, and it was that time when professor at that time, King, played pivotal role in attracting a lot of money from BP. I don't know if you remember this. Among other things he has done in her distinguished career. Obviously, she's a person that she has served UK in a number of ways. She's now as a cross-bench member of the House of Lords. She's also a member of the UK Committee on Climate Change, chairing its adaptation committee. And she's also the chair of the Carbon Trust. And she came here to Texas A&M as part of as a distinguished fellow of the Handler Institute for Advanced Study. And I would like also to say a few things about the pivotal role that the Handler Institute plays to the Texas A&M community in bringing these eminent scholars from around the world to the Texas A&M community. She has also authored the King Review of Low Carbon Cars, so something that was initiated by the British government in her role. And she has, she has a distinguished career. She started in academia with various posts at Cambridge and Nottingham. And then she joined Rolls-Royce back in 1994, where she became the head of materials and managing director of the Fund Systems business and engineering director of the marine business. So she has a very strong science and engineering background. Then she became the CEO of the Institute of Statistics, and in 2004, she appointed principal, the principal of the engineering faculty, the sort of the equivalent of Dean of Engineering at Imperial College London. And then she became the Vice Chancellor of Aston University from 2006 to 2016. And she really transformed Aston University from, to becoming one of the premier universities and schools in business and for professions in the UK. I would say a few other words, other than just emphasize, obviously, a fellow, also something that's not very unique, fellow of both the Royal Academy of Engineering and the Royal Society. And she was elevated to the peerage in 2015, as I said, being a crossbench member of the House of Lords. So I think she's very well positioned to give us her insight on climate change, net zero, and their quality of somebody who not only understands science and engineering, but transform this into policy and actual implementation, the UK perspective. So let's give the Texan welcome to Professor Julia King, Dame Julia King, Baroness Brown of Cambridge, all this. So thank you. Think great.
Well, thank you very much. It's been great fun to be here at Texas A&M University. I arrived on the 11th of October. Sadly, we're going back on Thursday, on the 27th, I think it is. But it's been a really fascinating visit and great to see so much good work going on here. I'm going to take you through some general material, some specific material that kind of walk through our perception on climate change, on reaching net zero, and on how that interacts with air quality from a very UK perspective, from very much the perspective of my work on the Committee on Climate Change, which I have been, well, I was for 13 years the vice chair of, and I now chair its adaptation committee looking at the UK's resilience to climate change. But let me start by talking about bit generally about climate change. So I hope there's something for everybody in this lecture. And I love data, given my background as a sort of scientist and engineer. And this is one of my favorite data sets, and I'm sure it's the kind of data that everybody who works in the agricultural part of Texas A&M will be very familiar with. But I just think this is the most brilliant data set because they so love their cherry blossom in Japan that it has been important to them since the early 800s to record the date on which the cherry blossom flowers in Kyoto. Now, isn't that the most beautiful thing that humans do? And they're so passionate about their cherry blossom that actually they've noticed that that date has come forward by about 15 days since the year 800. And almost all of that has been since the 1900s onwards. So a really interesting set of data that tells us something about the Japanese and their love of cherry blossom, but also tells us that climate change is affecting us in so many ways. This is data from the UK Met Office that shows how average global temperature has been changing since the 1860s. And as you can see, since the early 19th century, so 20th century, it has been going up pretty much inexorably. And since the 1980s, it's been going up really alarmingly in a fairly linear fashion. Well, that's that data again. And this is us thinking about what might happen in the future. So that's 2 degrees of global warming and 1.5 degrees of global warming. This is what at the Paris Agreement countries said they would try and stick to no more than 1.5 degrees by the end of the century, and definitely well below 2 degrees. And you can see how close we are already getting to 1.5 degrees. And there's a set of predictions from the Met Office for what it might look like if we manage to stay below 2 degrees. And we have just had the hottest decade on record. And I think that says to you that pretty much every decade between now and 2050 will be the hottest decade on record. We're going to get used to a lot of records. And that's if we can stay below average warming of 2 degrees. So that's if the world is on track for no more than 2 degrees of warming by the end of the century. It also tells you that if that's about 1.5 degrees, we could well be hitting that temperature as a global average by the mid-2030s. So a long time before 2100, sadly. And this is the range of warming we could see if countries continue as they are today. And it could be as bad as that. So I think that really is a world we don't want to leave to future generations. But the world today has been sending us some pretty strong messages that say it can't cope anymore. We had last spring, we had appalling flooding in Germany that killed some 200 people in Germany and Belgium. Of course, we've just had even more appalling flooding in Pakistan. But of course, in Europe, it's much more important for us to report flooding in Germany than it is for us to report flooding in Pakistan, but I bet it felt absolutely appalling in Pakistan. Actually, over the weekend, we had flooding in London. The third time we've had flooding in London this year. We've had 40 degrees C temperatures in Europe, which is, we have 40 degrees C temperatures in UK for the first time ever this summer. Of course, we had 50 degrees C temperatures earlier on in North America. We've had wildfires everywhere. Extraordinarily, our 40 degrees C temperatures meant we had fires in UK cities. The UK city fire brigades were called out, I think something like 10 times more frequency during the 40 degrees C temperatures in places like London and Manchester than they are normally. So we've had fires as a result of climate change, and of course we've had droughts in all sorts of places. So we are getting to a situation where climate change is having real and severe impacts, and also where the attribution science enables us to see just how much more common climate change is making events like this. And we're also starting to see people really take note of the increase in cost. So ignore the geophysical, because I don't want anybody to think I'm blaming climate change for earthquakes and the like. But meteorological, hydrological and climatological events are all likely to have a pretty strong climate impact in them. And we can see that in the decade through the 1980s, the estimate was about $357 billion of damage, but actually in the past decade, going up to more than $1.4 trillion of damage. And that'll be a huge underestimate of the costs of climate change. So from a UK perspective, we've had the hottest 10 years on record. It has felt like it. And indeed, we are now seeing down in the southeast corner of the UK, if you can say the shape has corners, we're now seeing that maximum temperatures are going up something like 1 degree per decade. And that's actually quite important because Cambridge is around here somewhere, but around this area of the UK is an area called the Fens, which is unfortunately lowland peat, but it is also a hugely fertile area, and it's where we grow a very large proportion of the UK's crops. That's significant because it's starting to see these very high temperatures. And these very high temperatures are having an impact on us. We tend not to have air conditioning in the UK. This was the very hot summer of 2018. This was a flat where indoor temperatures reached almost 50 degrees centigrade in September 2018. You could kill a baby sleeping in a flat as hot as that. So we have a lot of work to do to address our buildings and the changing climate in the UK, but we've got to also make sure it doesn't get significantly worse. So these are the predictions of water deficit in the UK. By the 2050s, if we're on that 2-degree path, there will be moderate water deficits across quite a lot of the UK. This is London, of course, all around here, so lots of people there. And this is East Anglia, where we grow all these crops. So beginning to be really significant and important. And of course, it's much worse if we're on a 4 degree, something closer to a path of 4 degrees of warming. And it may seem odd when we're worried about heat and drought, but we're also really worried about flooding. Because we'll see less summer rain, but much more winter rain, we will see much more preponderance to winter flooding. And even with the actions we're currently taking in the UK to reduce the risk of flooding, we're going to see a significant increase in the number of people whose homes are at risk in flooding by the 2050s, even if we're on that Paris compliant path. And perhaps I should just put for context, there are about 65 million of us in the UK, so it's quite a significant proportion of them. We're also seeing real problems with our trees. We haven't done as comprehensive a review as the Germans have done, but so this is from the German study. But climate change is causing damage because of wetter winters, hot, dry summers, and new pests and diseases that are becoming endemic because of the hotter, drier summers. And in Germany, they've done a big assessment of what proportion of their trees are now affected by climate change, and it's up at nearly 80% of many of their key species. And we're saying exactly this, we're seeing exactly the same sorts of things in the UK. So we've really got to rethink which trees we plant in which areas in order to address them. So here's where we are in the UK in terms of the climate change we've seen so far. Even if we're on that Paris compliant path, we're expecting to see average temperatures go up by about another 0.6 degrees. A heat wave summer like 2018 and indeed like 2022 will not be a 1 in 10 to 1 in 20 chance. It'll be a typical summer. We could see as much as 24% less rainfall in the summer and as much as 16% more rainfall in the winter. But we know we will see more of the rain coming as very heavy downpours, such as that which has caused, let's say, flooding in London now 3 times this year. The sort that causes surface water flooding because it overwhelms the drains, and of course because we're gradually concreting over our cities, so there's nowhere for the water to go. And we could, by mid-century, given we've had 16 centimetres of sea level rise already, we could see as much overall as 50 centimetres. And by the time we get to the end of the century, we're pretty confident we've got to build an even bigger version of the Thames Barrier to protect London from flooding. So that's what we're looking forward to. And that's a best case. That's if we can get the world onto a path to somewhere between 1.5 and 2 degrees compliant with the Paris Agreement. It gets worse if we're not. It's surprising, really, that we've taken such a long time to get round to this. We've known since the end of the 19th century, from various really key pieces of science, we've known pretty much how much warming we were going to get from the CO2 we're putting into the atmosphere from burning fossil fuels. So Arrhenius calculated that doubling CO2 would give us, based on the science that came before him, doubling CO2 would give a 5 degree sea rise in average temperature. Back then, the atmospheric CO2 level was about 295 ppm. Last year, the average was 403 ppm. So Arrhenius, if he were doing his calculation today with no more information than he had then, would say, well, we'd be seeing about 1.7 degrees temperature rise. Actually, we're seeing something around 1.2. Arrhenius didn't have the ability to understand how much of the heat was going to be absorbed by the oceans and other parts of the Earth system. But we've been able, since the end of the 19th century, pretty remarkably well on the basis of an awfully long time to realize we needed to do something about it. In the UK, I think we legislated the very first target, and given we've known about this since the end of the 19th century, it took us till 2008 to do that, and we passed the Climate Change Act, which said, committed the UK to reducing its emissions by 80% by 2050. It also created the Climate Change Committee, which I've been involved with since the Climate Change Act was passed. So UK action in that global context, actually the most crucial thing that we all of course reference now is the Paris Agreement from the COP in 2015, which was signed eventually by 196 parties to say that we would keep global average temperature to well below 2 degrees and we would make efforts to limit the increase to 1.5 degrees above pre-industrial levels. Since then, we've had the work of the IPCC in 2019 telling us that why 1.5 degrees was significantly better than 2 degrees and why we should really be aiming for the 1.5 degrees. And that spurred the government in the UK to ask the Climate Change Committee to say, could we change our target from an 80% reduction to net zero? And we did that review and we concluded that there were feasible scenarios, which were no more expensive than we thought back in 2008 it would cost us to get to an 80% reduction, because technology has come down in cost so much that we could feasibly get to 2050, get to net zero by 2050. And so very rapidly, the government amended the legislation. So we've only had one amendment to that 2008 Climate Change Act. It amends simply one number. It changed 80% to 100%. And then the year afterwards, the Climate Change recommended to the government what our path to reaching net zero should be. And then, of course, in 2021, we've had the IPCC's AR6 report, which is absolutely confirming that human activity is changing the climate in ways that we thought were unprecedented. And it comes up with the very ominous conclusion that although our models are predicting the average change very well, what we are actually seeing is, yes, the average change is roughly where the models are predicting, but we are seeing more extreme events, and those events are more extreme than our models were predicting. So that's really quite alarming, and things like flooding in Germany come into that more extreme. 2050, and of course we've had the COP in Scotland, and of course next week we've now got COP 27 in Egypt, and I know some of the students from Texas A&M are going, and I'm sure they'll have a really fascinating time on what I think will be quite a prickly COP, particularly given the things like the flooding in Pakistan and the problems that some of the global south countries have been having over the past year. So why did the UK think it should commit to net zero? Because actually the IPCC curves say that globally we probably need to be at net zero on average by around 2070 to have a greater than 50% chance of 1.5 degrees by the end of the century. Well, first of all, the UK committed to it because it has the capability to be more ambitious, because UK has already shown, and I've left out anything beyond 2018, 2019, because of the impact of COVID, makes the story so much more complicated. So I'm afraid I've cheated here. But the UK has shown you can increase GDP whilst also decreasing your emissions, and it's shown it can just about outperform the G7 on both of them, although I think outperforming the G7 on GDP is probably not true anymore. It should also go early, because although under Paris we measure territorial emissions, and we're doing quite well on reducing the emissions we produce in the UK, we really need to think about our carbon footprint, which is the emissions of what we consume in the UK. And because we're a big importer of manufactured goods, our consumption emissions are coming down much less fast. So we are responsible for a lot more emissions than those we produce. So again, we have a moral duty to think about trying to reduce our emissions fast. And thirdly, because as a developed country, we're able to implement technology and cost reduce that technology in a way which is useful to us, but is also useful globally. And we have, again, a moral duty to doing that. And this just shows the levelized cost of electricity from offshore wind, which only back in 2014 in the contracts for different auctions, because that's the way we contract for our offshore wind, was costing £150 per megawatt hour. And by the auctions in 2019, only 5 years later, this was auctions for the electricity, that things that would be built by the mid-2020s to the 2030s. So these don't yet exist. But the auctions for the electricity supply there, it has come down to less than 40 pounds per megawatt hour. So a dramatic fall in costs, just as we've seen for battery technologies, just as we've seen, in fact, for solar technologies. So really demonstrating that when the rich world starts to implement some of these technologies and scale, there is, just as the automotive industry at the beginning of the 20th century showed, there is huge opportunity to take cost out of these new technologies. So when we moved our target from 80% to 100%, it didn't sound like a lot, particularly to an engineer like me who tends to say, let's go with the 80% solution. But actually, when you look at how few years we've got to do that in, it actually is quite a significant change in slope of the path by which we have to reduce our emissions. So where are we? Well, again, 2019 is the easiest starting point because it's not affected by COVID. Well, we've been, in recent years, reducing the emissions from our electricity system quite fast. Most of that is taking coal off the system. Just towards the end, is starting to bring on more wind and solar, and in the UK's case, particularly offshore wind. Industry had been coming down steadily. A little bit of that in the early days is offshoring, but most of this now is genuine reductions in industry. Transport, sadly, despite all sorts of technology developments, has been persistently high. Buildings has improved a bit, but is pretty much consistently high. Waste, emissions from waste did very well with the landfill tax being brought in, but there haven't been any new measures since then, and that's rather flattened out. And then we see, I think, aviation has been creeping up, and of course, COVID's had very dramatic impacts on that. So, okay, it looks as if we might be starting to do well, but remember, we've got to get all of these down here. There's a long way to go, and we've got to make a lot of difference. And we've got some of those stubborn areas like transport and like buildings, which is mainly the use of gas in heating our homes in the winter. Stubborn areas where we're not seeing those curves really turn down towards zero. So the Climate Change Committee said to the government, okay, we've done a lot of modelling of how we might get to net zero, and here's the kind of things we need to do. This is about efficiency improvement and resource efficiency improvement, those purpley bits. This is about new low carbon technologies, so a lot of electrification, some hydrogen, and using CO2 capture from particularly industry. This is then, if you like, what we will get from expanding our low carbon electricity system in order to provide the electricity for all of that electrification. And then we're going to need to offset, which is why it's net zero and not zero. And as much of that as possible, clearly we should do with natural carbon storage. We are going to need technologies like greenhouse gas removals from the atmosphere by the time we get to 2050. So in the next 30 years, we have quite a big shopping list, government, in terms of these are the things you need to do in terms of policy if we're going to get there. So our electricity system has to at least double, treble in size to cope with all of the electrification. Our offshore wind, we currently have about 10 gigawatts installed and operating, just a bit more than that now, in fact. Our offshore wind has to expand by an order of magnitude to something like 100 gigawatts around our shores. And we're going to need floating wind as well as fixed wind in order to do that. We're going to have to completely transform our electricity grid. It's going to have to be much bigger, much more flexible. It's going to have to incorporate much more storage. It's going to have to be resilient to changing climate. We've got to develop a clean hydrogen industry. This is currently about what we use in terms of grey hydrogen, but we're going to need an order of magnitude more hydrogen than that, and it's preferably going to be green, but certainly green or blue. We're going to need to create a carbon capture and storage industry. We're going to have to decarbonize nearly 30 million buildings. We're going to have to change our car fleet. We're going to need the charging points to do that. We're going to have to grow a lot more trees if we're going to have those natural solutions to that remaining bit of emissions that we need to get rid of. So we're currently only 14% covered in woodland and forest in the UK. That needs to go up to about 18%. That's actually a huge change in the use of our land area. That will require major changes and improvements in the way we do agriculture. And we will also need to persuade people to reduce our beef, lamb and dairy consumption. Interestingly, that's already happened. It doesn't seem to be taking much persuasion. People seem to be doing that rather naturally. Underpinning that are really some very interesting changes in how we use fuel in the UK. So as I said, in our most efficient scenarios, and not all of them are clearly most efficient, but in our most efficient scenarios, our electricity use goes up from about 300 terawatt hours today to about 700 to 750 terawatt hours. In some of the less efficient scenarios, it goes up to 900 terawatt hours. So electricity needs to at least double in size, possibly treble in size. And as you can see, it just gets used across everything. But the particularly big growth, of course, coming in surface transport and also in production of hydrogen. So that's this turquoise bit along the top. Natural gas use falls by about 80 or 90%, such that by the 2050s, we're only using natural gas for electricity with generation with carbon capture and storage and for making blue hydrogen, so methane with carbon capture and storage. And that carbon capture needs to be at about 99% by the time we get to 2050. Oil use comes down again to about 90% reduction, such that pretty much all we're using it for is making aviation fuel by 2050. And hydrogen demand, now please note this is a different scale. This is a very exaggerated scale compared with the others. Hydrogen demand goes up from pretty well nothing, if we assume this is low carbon hydrogen, to nearly 250 terawatt hours. So we're building a hydrogen industry. We're going to build a hydrogen industry that's something of the order of the scale of our current electricity system in the UK, just to give a sense of scale. And we see most of that being used in industry. So that's M&C manufacturing and construction, and also being used as a fuel for shipping. So those are the two very big uses. Also in electricity supply, potentially as hydrogen turbines, but also being used very importantly for storage, for long-term storage in the electricity system. And I think it's quite important to understand what a dramatic change in use of energy this is for us. But today we use about 2,000 terawatt hours of energy in the UK, but only 300 of that is electricity. So in very simplistic terms, you might say we were 15% electric. We get much, much more efficient in 2050 as we move to electricity away from combustion, away from internal combustion engine vehicles. So we use about, in total, about half as much energy, but about 700 terawatt hours of that is electricity. So you might say we become 70% electric. And our government needs to recognise that incredible increase in dependence on electricity means we need a very marked change in the resilience of our electricity system, and in particular, the resilience of our electricity system to the change in climate itself. So where are we with delivering? Well, one of the things that governments don't like is trying to persuade people to change their behaviour. And we've achieved a lot from 2020 to 2008 to 2019, since the Climate Change Act was passed. Most of it's come from changing the electricity system, moving coal. So 83% of what we've achieved roughly comes from stuff where in my daily life, I don't actually notice whether that's low carbon or not. I haven't had to change how I behave. So that's been pretty easy for governments. As we move forward, only about 40% of it comes in the easy bucket, where your voting public don't have to change what they do. But about 60% of it involves people making different decisions and behaving in different ways, which means governments have got to persuade people who vote for them to do things they may not want to do. And that's the bit that politicians absolutely hate. On the other hand, there are some positives. When back in 2008, we did the assessment for reducing emissions by 80%. We said we thought it could cost up to 2% of GDP to reduce our emissions, and that was felt to be a reasonable cost for the benefits, because that wasn't taking into account the impacts and the costs of the impacts of climate change. Doing the analysis again in 2019, we came to the conclusion that it would cost around 0.5% of GDP at worst, because the technologies have got so much cheaper. And actually, further analysis suggests that with the new industries that will be being created, actually, that will be combating that with GDP growth from the growth of green industries. And so actually, it will be financially positive for the country to do this. And that's been a hugely important part of keeping the politicians on board. The challenge they have is that there's lots of cost savings from electrification, but almost all of those cost savings, there's lots of investment needed, up to 50 billion extra investment in infrastructure per year in the UK. But as that investment comes through, there are lots of cost savings. But almost all of the cost savings come in transport. So the operating costs of transport become much cheaper, and the capital costs don't increase by that much. But for the other areas where the capital costs are increasing, the operating cost savings are relatively small. So you've got to think about, how do you make the tax system work to redistribute these benefits in transport in order to help fund the capital costs that we're going to need to decarbonise other parts of the economy. So that's something that our Treasury doesn't like very much. They quite like the fact that by 2050, it's cheaper to be net zero than not, but they don't like the fact that they're going to have to redistribute, use the tax system to redistribute the savings. However, we do now have a net zero strategy published last year, and actually I think we can honestly say it is a world-leading net zero strategy. It sets out a range of scenarios that can get us to meet our target that we committed to at COP26 in our NDC, which is a 78% reduction by 2035 and then net zero by 2050. It covers all sectors of the economy, doesn't involve us buying international carbon credits. It draws very closely on the Committee on Climate Change's work, so we're pretty supportive of it. It does have a very strong focus on technology over persuading people to do different things, so it's more expensive than it would have been if you were prepared to talk more about demand reduction. And it does talk about enabling people, but it doesn't talk about the government having any role in that. And that's partly because our Conservative government doesn't like to be thought of as a nanny state telling people how to live their life. So as you see, there are some internal tensions in the ambition, and our assessment of it is that it's good on surface transport, which contributes 23% of our emissions. It's good on power generation, which is currently 11% of our emissions. It's kind of not too bad on buildings and industry, and it's pretty poor on agriculture and land use. And these are the percentages of our emissions that those parts of our economy represent. So one of the things we have to think about quite a lot is, how else do we sell this politicians? It's useful to be able to say, and the co-benefits of this. The biggest co-benefits are, if we can convince them it's a way of growing the economy, and we have growing data that suggests it can be a way of growing the economy, and indeed it can be a way of actually putting manufacturing jobs back into the north of the UK. On the east coast, on the northeast coast, which is the sort of central hub for much of the offshore wind industry in the UK, we have two towns on the coast which are quite close, which are called Hull and Grimsby. Grimsby is unfortunately a town which rather similar to its name. It was formerly a big centre for fishing. The fishing industry left Grimsby, I should think, between 150 and 100 years ago. It's been a very, very deprived town. Similarly, Hull is adjacent to it. And that's become a very deprived town as well. Since the offshore wind industry arrived, there's a big Siemens blade factory opened up in Hull. The knock-on impact of that has been to reduce male unemployment in Hull by 50%. Grimsby now has Ørsted's European control centre for all of its European wind farms, which is growing a new highly skilled population in that area. And you're seeing regeneration all around that area of the coast, economic regeneration. So that's one good way of getting the government to think this is a very good thing, and that supporting those big capital investments with government money is actually delivering for the country and will win them votes. Air pollution is another of the key areas of co-benefits. It's responsible for over 7 million premature deaths globally every year. It's responsible for something like 28 million, I think I've got the numbers wrong. It's responsible for huge numbers of premature deaths globally every year, and also hundreds of premature deaths every year in the UK. And apologies, the numbers have just slipped my mind for a moment. So there are lots of possible co-benefits of for air pollution and climate change. One of them, of course, is particulate matter. So as we take out coal plants, as we decarbonise industry, as we decarbonise our vehicle fleet, the amount of particulate matter in the atmosphere comes down, particularly those PM 2.5 ton particulate that can cause not only problems with chest infections and things, but also even cancer. But we have to be careful, because one of the things we're doing in making our homes more efficient is we're also insulating them better. And we've got to be very careful that we balance that with looking at how do we maintain high quality indoor air quality, not just sealed homes. And we've had a few problems with really significant impacts on indoor air quality as we've done some extreme insulation of homes in the UK. We've also got to recognise that we may well be going to biomass combustion, replacing some of the coal combustion. We're seeing very significant increase in wildfires, which of course contribute to air pollution and particulate matter. And electric vehicles doesn't solve all the problems, because we still get emissions from tyres and brakes. And if we have more and more private cars and things, then actually those emissions from tyres and brakes will start to be going up. So there's a pretty big positive, but it's not 100% positive. In terms of ozone, in general, we don't predict huge changes in ozone levels, but we do need to recognise that if the methane emissions grow, wildfires and hydrogen combustion and higher temperature generally can increase ozone. So if we're not careful, we may see some increases in ozone levels. Nitrogen, well, actually one of the ways forward in agriculture is obviously to reduce the use of nitrogen containing fertilizer. So we should be driving reductions in NH3 emissions from agriculture with the net zero policy. But actually we have the challenge that the climate is getting warmer, and that will tend to drive nitrogen emissions from agriculture up. So there's a real challenge that NH3 emissions will grow, and we do need to make sure, in line with reducing emissions, that we have a very strong focus on reducing nitrogen emissions from agriculture. NO2 emissions should decline steadily as a result of our net zero policies, particularly moving to electrification. But one of the things we have to keep a very close eye on is actually combustion of hydrogen. Hydrogen combusts at a higher temperature than methane. So there's a real danger, if we don't get the combustion conditions right, that we start to oxidize the nitrogen in the air, and we get both NOx and ozone increases. And we still don't yet know enough about that. So that's one we've got to keep an eye on. And volatile organic compounds, VOCs, industrial emissions should reduce that. but we do need to be careful what trees we plant, particularly in our cities, because some of the more ornamental ones have quite high VOC emissions, and that's something that people designing green space in towns and cities are often not very aware of. So in general, there's a really strong message that says, if we get the policies right, we can deliver very significant air quality improvements as part of the way we deliver net zero. But we've got to make sure that we think about getting our policies into, ideally, this bit over here, where we improve both air quality and get a climate change benefit. And we've got to avoid absolutely this quadrant over here. But there are some things which are absolutely win-win. One of them is decarbonising the power system. One of them is getting people out of their cars, walking and cycling. And win-win is the improved efficiency of managing nitrogen in agriculture. So there is a real opportunity, but we do need to make sure our legislators are aware that actually we can do the wrong thing as well as the right thing. So I'm an optimist. I was brought up very close to Salisbury Cathedral when I was very small. It's an absolutely magnificent cathedral if you haven't had the chance to see it. It's an absolutely stunning building. The people, the craftsmen who started work on the cathedral had no idea what it would look like when it was finished. It took 300 years to build. They weren't even alive when it was finished. But they had a faith. They knew they were doing something really important. And I love this quote from Greta Thunberg, which says, all of this needs cathedral thinking. Thank you very much.